I am pleased to present to you our lab bottle blow molding line type LBM125. This is a 3-layer version. We also have it in single layer and 2-layer versions, but the most popular now is the 3-layer versions. And we have here connected the bottle blow molding attachment to 3 extruders, as you see here. And the extruders are of size 20 millimeter, but this attachment can also handle a little bit larger extruders of 25 millimeter. But usually 20 millimeter is enough for this small bottle. The bottle size here is only 125 milliliter. The extruders we use here are of the new type, which are with one single pillar, which are very practical and have a very small footprint, as I will show you here. If you look at the extruders here from the rear, you can see that they they are very narrow, so you can put 3 extruders together and they don't take out too much space. These extruders are also very good for co-extrusion application, where you have many layers, up to 9 or even 11 layers. Now 11 you cannot, but with 9 layers you can have all extruders on the floor, same way as shown here. With this version you have a central control panel which controls the speed of all 3 extruders, and here you can set the speed individually, the RPM or screw speed individual for each extruder, or you can also set them in a synchronous mode so that they work together. Now in this case here they are already set up in a synchronous mode, and all 3 extruders are running with 62 RPM. On the top here of the panel you have the temperature controllers to the adapters which is going into the die. And then, of course, on each extruder, you have individual control panels, so where you can set the barrel temperatures, and you also here can see the motor load for each extruder, as well as the RPM. So the RPM is also shown here on the central control panel. Now for this bottle we are running now, we are using HDPE for all 3 layers, and we use red master batch for the 2 outer layer, and the inner layer have a white master batch, so we can distinguish the layers on the bottles. And with this you can see how good the layers distribute. And here under the covers you have the adapters. They're also attached here with C-clamps, so it's very easy to disengage the extruders, to remove them. Also easy to move the extruders back if you want to take out the screw, for example, for special cleaning purpose. So here we have the die. It's of course a 3-layer die with a new design actually, which gives a very even layer distribution. It's perfect for co-extrusion or bottle blow molding. And on top of the die here, you have an inlet of air, which you inflate the horizon coming out of the die to prevent it from collapsing before you be molding into a bottle. And in between here you have also an adjustment possibility of the thickness of the horizon, the total thickness only. The layer thickness for each layer, or the thickness for each layer, here this is the nut you regulate the total thickness. The layer thickness you regulate with the speed of the extruders. And now we are running the bottle here. You can see the bottle is now being inflated by the inflation device. And on the left side here you have a bottle hanging which has just been completed. It's just hanging there to cool down a little bit before it drops into the tray. And now the mold catches the parison and the new bottle is being blown up. And as you see, the parison is coming out all the time. So you synchronize the parison speed with the amount of the length is coming out, so it is correct with the bottle size. So this you have to set from the speed of all three extruders together. Here is a close-up. You can see the mold clamping the parison, and the hot knife is cutting the parison. Once the mold has clamped the parison, it's cut off with a hot knife cutter. So you see it again, yeah. Yep. There you saw it got stuck a little bit on the knife, but it doesn't matter because that part of the parison is below the bottom of the bottle. So you see the cut again. So this is a control panel for the bottle blow molding attachment, where you have a touch screen here, where you can set up the various parameters. So we can change the screen here by pressing one of the buttons here, and you get to another screen where you can set up the parameters, the blow pin, and you can set up the timing for all the various functions here. So this is very easy to use and easy to understand once you have read the instruction manual, of course. So here on the lower part of the control panel you have all the start and stop buttons for the hydraulics, for the functions of the clamping, and on top and so far, and on the top you have the temperature controllers for the die. And of course I forgot to mention that in this case, because we are making the video, we are running with an open door, which is not allowed to do, but you have to overrun the safety, which we have done. But usually the door has to be closed. We will show here. Right, this is how it has to be when it is running with a closed door. And if you lift the door, the machine will stop. I think that's all about this machine. So here we have some samples of the bottle we just produced, and we have cut them up so that you can see the layer thickness here, or the layers. And you can see here on the mouth of the bottle, you may be able to see that it's a very even layer of the white. I think it's out of focus here a little bit, huh? And also here you see the bottle we have cut open here. You can see the white layer, I hope, in between the red layers, and they are really very even. And this is very important in co-extrusions, that you have a good layer distribution in order to improve the quality of the bottle. And here's another cut we made on the same thing. You can see the layers here also. On the other side you can see the mouth of the bottle. Very nice, even layer, if I may say so. Thank you, that's all.